I think so. Alrighty.
Yeah, it's good.
So let's have a look at Amos. Yes. So I was going to go through 3 models, a 5-factor uncorrelated, a 5-factor correlated, and show you a thing or two about modification indices. So this data set, I think, might actually be the same as last week. It's a test measuring the big 5. You've got 5 items per factor. So things like, I'm indifferent to the feeling of others, inquire about others' well-being. And you've got a couple of data files here. In theory, if you're going to do this in a rigorous way, you might develop a model in the exploratory and apply it in the confirmatory. But we'll just focus on the exploratory. So to open up Amos, it's probably in all programs somewhere, but otherwise you can just type in Amos down here, and there it is. Amos Graphics is the one you want. So the screen you get, obviously it's very different to SPSS. It's a different program, although it does interface with SPSS data files. Before we can really do anything, we need to get a data file into Amos. So we need to connect Amos with data. To do that, we go to File, Data Files. And from there, we'll get this box. And if we click on File Name, we can open up our SPSS data file. So that's Documents, CFA, data. Okay, so here we are. So I've double-clicked on the data file, and it's telling me I've got 1,236 cases, and all of them are selected. Okay, so I've now connected Amos to the data file. If I want to see the variables in my data file, I can click on the stack of pancakes here, white stack. So what we see, if we could open up SPSS and see this, but what we've got a bunch of variables representing the items. So A1 to O5 are the items. And then there's a few other demographics and IDs and probably stuff from last time floating around. Okay. So we'll use that later on, but first let's have a look at what else we've got in Amos. We've got this huge toolbar of stuff. We've got drawing tools, so we can draw rectangles for observed variables. So it's a drag and drop operation. So press the mouse button down and drag and drop.
Yeah, if you get any more that way.
Okay.
Just a heads up.
Heads up. Okay. So yeah, you can draw observed variables. You can draw latent variables. So that's with this ellipsis tool. So it looks like that. So it's holding the mouse button down, dragging, and letting go. You can draw these latent factors with observed indicators. So you first drag and drop the initial latent factor, and then you click on it. You can have as many items as you want. So that's what you'll use to create basically typical psychological constructs where you've got some items representing a factor. Okay, so if you start drawing some stuff like this, you can use the truck to move things around. You can photocopy an individual icon. If you want to move a bunch of stuff, you could select them one at a time. They go blue. And then you could get the truck and you could move them all around together. Or you could unselect just one and then move just those two. Or you could photocopy those two. And so on. So anyway, there's lots of tools in there for drawing diagrams. So we want to draw a model with 5 latent factors, where each factor has 5 items. So basically we want to use this tool, this latent factor with observed indicators, to draw a latent factor, click it 5 times, and that's going to represent one factor ultimately. That's going to represent, say, agreeableness with its 5 indicators. It's important to get the size right to begin with so that this is going to fit on the page. So I'll maybe do that again because I'm not happy with that. Just if you draw things neatly, everything will be easier. So let's try that again. I'll do a sort of a slightly smaller one. 1, 2, 3, 4, 5. You can use the rotation tool to get it in a nice direction. Select all. I'll move this one up to the top of the page. So I've got one of them now, and I want to have 5 of these. So I'll get the photocopier tool and copy it down.
So there are no values that any of these things are there? Yeah.
They're completely empty for now. So yeah, I'll unselect, and so at this point now I need to start adding variable names. So the first thing you do is you connect the observed variables to the observed variables. So you can double click on this, and I could type in A1. And that would be enough for this to connect to this. So for this observed variable A1 to connect with this variable. But usually the safer way, so you avoid typos and a few other things, is to drag and drop the observed variable in. So drag A1 in there, A2 in there, A3 in there, A4 in there, A5 in there. So that's connected that observed variable with the variable A1. It's also copied the label over from SPSS as well. The label's purely there for display purposes. And if anything, it's actually a bit annoying, I think, to have all this text. So I'm going to actually just hide that stuff. So in the view interface properties, you can actually hide these labels. Just unclick that. So you don't have to do that. I just think it's easy to see what's going on like this. So yeah, we'll drag all the rest in, C1, C2, one at a time. And you notice how, because it's been drawn fairly neatly, it's easy to see each box, and it's easy to see what names and symbols are in each bit. So that's kind of important because it's very easy to sort of drag the wrong item into the wrong thing. So if you can visually see what's going on, life will be better. So yeah, a bit of dragging and dropping, but that's the price we pay. Yeah. So once we've got all our indicators named, so we've connected all the observed variables, we now need to name our unobserved variables. So we have 2 types of unobserved variables. We have our latent factors, so an agreeableness factor, a conscientiousness factor, extroversion, and so on. And we also have these residuals. So we've got a latent factor, agreeableness, so I'll just call it agree. There's nothing special about these names other than they can't be a name that's already in the data file. I'll call this one, conscientiousness, extroversion, neuroticism. Notice that I'm putting it in the name. The label is optional, the name is compulsory. Yeah. Then I need to name my residuals. If you don't care about the names of the residuals, there's a plugin that will just give them standard names like E1, E2, but I think it's quite good to give them meaningful ones most of the time. So I'll just call it EA1. because that's the error or residual of item A1. So giving it clean names will then make it easier when you're looking at modification indices to talk about if you want to correlate a residual or that sort of thing. Oops. So yeah, a little bit tedious, but not too bad.
Are you just double clicking on these and then type?
Yeah, I think so. It should just stay selected in that. So I'm clicking and just typing.
Jeremy,
Yeah.
the items that you dragged in, that's the non-reverse ones, yeah?
Yeah, I dragged in the non-reverse ones. So it's kind of like factor analysis. You should see negative loadings
Yeah.
if you've got a negatively worded item. Although we will come to the issue of how to make sure that the factor is measuring agreeableness and not disagreeableness, which is just, it's important to be aware what the direction that the factor is taking. But, yeah, non-reversed is probably better because then you can see, oh yeah, that's a reversed item and it has a negative loading. So almost there. Okay, so we got there. So what we have is our named observed variables, our latent factors, and named residuals. So what we might want to do now is run this model. Get estimates of parameters, look at the fit. So before we do that, I'll just click on this abacus with the options. There's a bunch of things that you can learn over time, but the key things that you almost always press is output. It actually gives you very minimal output to begin with. You almost always want standardized estimates. So that'll give you things like correlations instead of covariances, and standardized loadings like beta weights instead of unstandardized. You might want to see sample correlations and implied correlations. We'll get to modifications and residuals later. Okay, so when we're ready to run it, we click on the abacus symbol, and always remember to save your Amos file before you try and press the abacus thing. Otherwise you'll get that error. So I will save this. I'll call it Model 1 5-factor uncorrelated. And I'll try and make sure I put it in the same folder as my data. That's probably good advice. Okay, so now I've saved the model. I can click Run. And it's telling me that these factors are uncorrelated, and that's probably not a good idea. But if you're happy to do that, you can. So we'll just proceed. If we've got success, which probably when you first start out with this stuff you won't, but if you've got success, you'll see an up arrow here. If you click on that, you'll go to sort of results output mode. By default, it's showing the unstandardized loadings, and probably you want to look at standardized. So you can look at the model, and what you've got there are the loadings of each item on, say, the agreeableness factor or the conscientiousness factor. They're the same as what you get in, say, a pattern matrix for an exploratory factor analysis. So item C1 loads 0.55 on conscientiousness. Item C2 loads 0.60 on conscientiousness. So you've got all your loadings displayed there. For more information, we click on this this sort of spreadsheet-looking thing that gives us our more detailed output view. So let's go through that and talk about some of the things you get. You get the date and time that you ran the analysis, nothing exciting there. You get your sample size. It reminds you what your observed variables were, so they're all the items, as well as the latent variables, the unobserved variables you've got. So we've got our factors and all our residuals. It tells you how many of each you've got. It tells you how many parameters are being estimated. So I think you're, in this model, estimating, well, a range of loading parameters and variances for factors and then residuals. You've got the sample moments. Moments, you know, you probably think, you know, oh, a moment is I had a nice time, I had a connection with someone, I had a moment. But in statistics, a moment is, so when they talk about moments, they talk, the mean is a moment, the variance is a moment, skewness is a moment, kurtosis is a moment. So the first moment is the mean, the second moment is the variance. So Amos is the analysis of moment structures. So it's the analyses of means and variances and covariances. So sample moments is just a stats way of saying sample means and covariances and so on. So we've got the covariance matrix, but yeah, you've also got the correlation matrix. So I don't know. If you wanted that, you wanted to see, this is kind of the structure that we're aiming to reproduce from our model. So if our model's not able to reproduce the sample correlation or covariance structure, then it's a poor fit. So we have, I guess, the raw data is in a sense our covariance matrix, and our model is trying to reproduce that. So we have 325 sample variances and covariances. Basically, if you added up all these cells, you'd have 325. And we're using only 50 parameters to estimate those 325 bits of information. So in that sense, they say the degrees of freedom is the number of parameters minus the degrees of freedom. So minus the degrees of freedom is the number of sample moments, i.e. 325, minus the degrees of freedom. Minus the number of parameters, yeah, is the degrees of freedom. So in a sense, the fewer parameters you have, the more parsimonious your model is, the simpler it is. And in general, we like simple models that fit the data well. But there's often a conflict between those two things. So the chi-square describes the degree of discrepancy between your sample covariance matrix and the covariance matrix implied by your model. It's not that meaningful in isolation, but it is an index of discrepancy. So we can start comparing this chi-square to other models in the future. We also get all these parameters. So these parameters are actually displayed in the diagram here. 0.41 minus 0.68. But you also get it here as well. So standardized loadings as well as unstandardized ones. And the unstandardized ones also include standard errors and critical ratios. So this is kind of like a z-test or a t-test. So if you remember, if z's larger than 2, mean that the value is significantly different from 0. So in some contexts that will be important, but yeah. You can also get variance estimates and so on. You get various implied covariance and correlation matrices. So this is the correlations between the items implied by the model. So because we've got uncorrelated factors, the items across factors aren't allowed to correlate at all by the model. There's no capacity in the model to allow an openness item to correlate with a neuroticism item, for example. So that's why all the implied correlations across factors are zero here. Anyway, this is sort of, I guess, generally one way of seeing how the model might be failing if the sample correlations do include some sort of small 0.1, 0.14, 0.2 correlations, but the structure we've imposed requires all the cross correlations across factors to be zero. So maybe we need to improve our model, is what I'm getting at. You can often look at these residual covariances to suggest where your model might be failing. So large residual covariances can suggest aspects of the model that are not being reproduced. Anyway, an uncorrelated factor model is not the best in general. You probably want to correlate factors, so it's not surprising that there's lots of problems with this model. You also get a wide range of model fit statistics. The default model is what we just ran there. These are what we can ignore. There's a lot of stats here, but we've got the chi-square here, the C-min, degrees of freedom, p-value. We can get the RMSEA with confidence intervals. And we've got the CFI here. You can click on these things to learn a bit more about them, which can be handy. You can also see that you can get, there's these little things called text macros. So one thing that's quite nice, if you want to get a picture of how well a model fits at a glance, is to use these little text macros. So /CFI, /CMin. And you combine that with this title tool. So we can write things like chi-square equals CMin. So that was /CMin. Let me move it. Chi-square CMin. Anyway, and when we run that, it's not very neat, but the value of CMin gets filled in. So the value of chi-square gets put on the graph. So let's see if we can just make this a bit prettier. There we go. So yeah, so now we've got that displayed on the plot. So usually what you do is you pick the stats that you want to see, like CFI equals CFI, maybe degrees of freedom, the p-value, maybe the RMSEA, and yeah, if you run that, you've got the stats for that model. Okay, so that's one example. It's probably a lot to take in, but just by way of example, what you'd usually do is test a few different models. So a very common thing to do would be to correlate a few factors. So I'll save this as a new model. I'll call it model 2, 5-factor correlated. And I'll add correlations between these factors. So you can just drag and drop you start from the bottom, it will draw it this way. Drag and drop. Basically do this for every single pair of things. Or the shorthand, which is much nicer. Is to use the macro. So if I can actually delete these things somehow. So if you select all these factors, 2, 3, 4, 5, and go to plugins, draw covariances, it'll save you a bit of hassle. So now when we run that, we've got new fit information. So probably what you'd usually do is create a little Excel spreadsheet where you have like Chisquare, DF, P, RMSEA, CFI, some other stuff, and you say uncorrelated 5-factor, and you'd record the information from that first model. So, for example, the RMSEA was 0.09. You do it for all of it, of course. And then you'd repeat with a correlated 5-factor. Now the RMSEA is 0.077. So you'd add all that information and go, oh look, the RMSEA has got better. Clearly it makes sense that a correlated 5-factor is better than an uncorrelated 5-factor. Another minor point here I should mention is in order for these latent factors to have a scale, you either need to constrain one of these loadings to a value of 1, or you need to constrain the variance of the factor. And just one thing to watch out for with when you've got scales with reversed items is to make sure you put the 1, so this is constraining this unstandardized weight to 1, on a positively worded item. So you'll notice on this scale, actually item 1 and indifferent to the feeling of others, it's a negatively worded agreeableness item. Whereas inquire about others' well-being is a positively worded item. So probably we want to put this 1 on A2. So we've got this regression weight. So we take that off A1 and put it on A2. So that will ensure that the meaning of the scale is correct. And I think if you go through this, you'll see that and the extra version is the same. Don't talk a lot, so we should take that off as well. And put it on E3. Know how to captivate people. So yeah, after we do that, then these correlations will make a lot more sense in terms of this is actually representing extroversion rather than introversion. This is actually representing agreeableness and not disagreeableness. The final thing I wanted to show was modification indices. These are things that let you suggest improvements to the model. So under options, you can ask for modification indices. And so if you run a model with that and go to the output, you'll see these things called modification indices. And these are a whole pile of recommended changes that you could make either by adding a covariance or a variance, or a regression weight. They're not organized in a particularly friendly way, but you can suppress small ones, I think. Or one option is to, I don't know how you do it, you copy the whole matrix into Excel and I guess sort it. Data sort. Excellent. So sort by the MI, so it's column D, I guess largest to smallest. And so saying the greatest increase would be to add a correlation between EN4 and extroversion. In general, there's two types of cross-loadings that can make sense in this sort of context. One is correlations between residuals of items. They can sort of make sense. If there's something, I'm guessing there's something particularly common between neuroticism item 1 and neuroticism item 2. That if we were to look at the text of neuroticism item 1, get angry easily, neuroticism item 2, get irritated easily, they're just so close in meaning. They're more close in meaning than, say, get angry easily is to panic easily, I guess. Maybe angriness and irritation just more similar. So if you wanted to capture that, you could put a double-headed arrow between EN1 and EN2. Perhaps save this as a new model, 03 modified or something. Pretty bad name. And if you rerun that, you'll see that, well, maybe 0.073, we've got a slightly better fit. So you could do that sort of process to quite a few things, sort of improving the model. Yeah. Anyway, that's probably it for the video. I'll leave it at that. But